We're in Chapter 2, Section 1 of the Tech Math book, and this is Tech Math 2. Okay, so this is a review of geometry. The first thing we have to worry about are lines. Now, the definition of a line, if I could spell line, is if I have 2 points, then I can make a line. So if I only have 1 point, can I have a line? Well, I might have a line if I only have 1 point, because the line could be coming straight out of the board at me, right? And I might be looking at it dead on. So there's a section of geometry that is not plane geometry, but a different level of geometry that says points and lines are the same thing. Okay, but that's kind of weird. We don't have to worry about that. But you could develop a geometry where points and lines are the same thing, because that's clearly a line coming out of the board. 2 points make a line. In plane geometry, what you taught in 10th grade was 2 points made a line, and you weren't confused by anything else. And then we have angles. And so I have 2 lines coming together. I have some angle measurement between them, normally in degrees is what those guys are in. The angle has a vertex. The point at which those 2 lines hit each other. We could say this was angle 1, or we could say this is angle A. We could do that and be perfectly okay. Angles can be right angles. So now I got a right angle. I know when we put a thing like that, it says it's 90 degrees. So I got a right angle that's 90 degrees. I have acute angles. And Nate, for example, he'd be an acute angle, right? No? Okay, so an acute angle would be something less than 90 degrees. So my so angle A less than. Now, how do we know the difference between a angle sign and a less than sign? Well, clearly you can't tell the difference by the way I write it, but in general, an angle sign is like that, and a less than sign would be like this. So this would be a flat side. So that's more flatter than that is. Sure it is. Yeah, I can see that. The author won't have any problems with that. And so we could have acute angles. And then we could have obtuse angles. And I'm an obtuse angle. And you guys will be too, but you have to get at least a 63 before you are. So right now you got many years away before you can be an obtuse angle. And that's an angle that's greater than 90 degrees. Angle A greater than 90 degrees. All right. I have 2 lines, and they could intersect. They could do something like that. Oh, I have another angle. Normally I forget about this one, and I did again for another year. But we could have a straight angle. S-T-R-A-I-G-H-T. So there's a straight angle. There's the vertex right there. And it's 180 degrees. Only on an SAT test would you have somebody do something silly and put a straight angle on it and have that try to confuse you. But vocabulary-wise, we have right angles, acute angles, obtuse angles, and a straight angle. When 2 lines cross, we have an intersection. So you have an intersection. The vertical angles are going to be equal, so this angle A is going to be the same measurement as that angle A. They both had a measurement of A. And these sides over here, they're the same as well. And it'd be better if I had a better drawing, so we'll have these guys cross like that. And we're going to say that the measure on this side and that side are the same. These two guys are the same. So if I put a single line, that means that's the same both sides. Double line means double lines are the same both sides. I don't necessarily, lines don't necessarily, if they do cross, they make a point. So two lines make a point, cross and make a point, or the two lines could be parallel. So I could be parallel, if I could spell parallel, P-A-R, way to go. Did I get it? Maybe. Parallel. Oh. Second time. Third time? Oh, what's that A doing at the end? Oh, I don't believe it. Who did that? As obviously, so if they're parallel, then they don't intersect. Okay, so that's perfectly okay. Now, do parallel lines ever intersect?
No.
Yes. Parallel lines on a globe, on a sphere, will intersect twice. So if I'm dealing with spherical geometry, then I've got this line which is the equator, and I have this other line which goes to the North Pole and back, and so parallel lines will intersect twice. No? All right, well, forget about that. Right? This is plane geometry, so we don't have to worry about spheres. Okay, just another weird thing, you know. Also on a sphere, well, we don't want to know that either. Anyway, so you didn't want to know that, so we won't put that down. The other thing that could happen is that lines could be the same. So here's line 1. And here's line 2, right on top of line 1, well, almost on top of line 1, line 2. They could be the same line. Line 2. Okay, and that's an important distinction because what's the equation of a line? Well, the equation of a line is going to be ax plus by is equal to c. Could be an equation of a line. And so I have two equations, a1, b2, a1, b1, c1, a2x plus b2y plus c2. Now I have two equations, and I want to find the answer. Two equations, two unknowns, I want to find the answer. Well, it could be they intersect and have one answer. It could be the lines are parallel and have no answers. It could be the lines are the same line and have multiple answers. So that's how we come across those things. Two angles are adjunct angles. Okay, well, that's adjunct, adjacent. Adjacent angles. In order to be an adjacent angle, you have to have a common side. So there's angle A, angle B. Angle A and B are adjacent. They're next to each other. Two lines can be perpendicular. So if my two lines are perpendicular, then they form a right angle. So I've got a right angle on all four sides, and isn't that great? It looks like I have a square going around an XY plane. But I don't. I really have a right angle. Let's see if I can... okay, that's good. We'll only put one right angle in. I only need one right angle because adjacent angles are vertical. So this has to be a right angle on that side. It's a line, so it's 180 degrees, so it's got to be 90 degrees on the other sides as well. Okay, so now I got perpendicular. I have adjacent. What do I have next? I have complementary. I tell you, the second time it goes forever. Complementary, M-E-N-T-A. We had the option of calling these things anything we wanted to. Why couldn't we use some single syllable word? Why did they have to come up with complementary for? And it probably has to do with the 100-year war and the 30-year war in Europe. It's so much bad blood between the British and the French that when the French came up with something simpler, and I'm assuming they did, the British said, we're not going to go that way, and they came up with something completely different. Anyway, complementary angles will add up to 90 degrees. So if this is 55 degrees, then the other side has to be 35 degrees, because the sum of complementary angles has to be 90 degrees. That has to be the way it is. So I got a 90-degree angle there, and I got 55 and 35 adds up to 90. And after complementary angles comes supplementary angles. My same discussion goes on this guy here, that we could have picked any word we wanted to at all, and we had to have one with 1, 2, 3, 4, 5 syllabi, just to complicate the matter. Complementary angles, supplementary angles will add to 180 degrees. So this guy is what this guy looks like, 37 degrees. So the other side would be 143 degrees. And you're going to remember that because of the alphabetical orderedness of complementary and supplementary. So C comes first, C is the 90, S comes second, it's 180. So because it's in alphabetical order, that's the way we remember it. Otherwise, we're just not going to be able to remember it. It's just silliness. Okay, I think I already did vertical angles, didn't I? Vertical, boy, that was good. Spelling vertical with an S. That was very good. E-E-R-T. So vertical angles. And vertical angles are equal. So I got guys like that. Angle 1, angle 2. Angle 1 is equal to angle 2. Angle 3, angle 4. Angle 3 is equal to angle 4 because they are vertical angles. No other reason. All right, then we do the transversal thing. Transversal. That sounds sort of like a French term. Could be, I suppose. So I have two parallel lines. Line 1, line 2. And line 1 is parallel to line 2. If I could spell line 1, which I didn't do a very good job of. Line 1. Okay, in that case, then the transversal is something that goes through those two guys. Now, in that case, alternative angles are equal. So this is angle 1. This is angle 2. Angle 1 is equal to angle 2. Vertical angles are equal. So angle 3, angle 4. It's equal to angle 3, angle 4. Likewise, the guys in blue are all going to be equal. So all alternating interior angles are equal, alternating exterior angles are equal, vertical angles are equal, all kinds of things. Now, your transversal doesn't necessarily have to cross two lines that are parallel. So I could have two lines that are like that, and I could have a transversal going like this. Then I could say, well, because we're not parallel anymore, those two are the same, These two are the same because they're vertical angles. These guys are the same because they're vertical angles. And these guys are the same because they're vertical angles. But I can't tell anything about what's up there and what's down here anymore because I'm not parallel. So I can't do anything about that. Corresponding angles are exterior, interior angles on the same side of the transversal. We already covered that. Ulterior angles, blah, blah, blah. Okay, so it looks like we're done with everything except working problems. So we'll look at number 1. Name, okay, use figure 24, okay, I got it right there, 24:14. Okay, I see the figure. Name 2 acute angles. 2 acute angles. Okay, so acute angles. Anybody got one? Angle 2 and angle 3. That they're the same measurement is okay, but I don't really care. Okay, number 2. Name 2 obtuse angles. Obtuse. One and four. 1 and 4. Number 3. 2 right angles. It should be this simple always, right? 5 and 6. How could it be anything other than 5 or 6 are the only guys left, right? Number 4. Name 2 acute vertical angles. Okay. I want to be acute, and I want to be vertical both. Yep, I don't have much of a choice. I have 2 and 3 again. Unless I label something else, which I'm not going to do. 5. Name 2 obtuse vertical angles. Obtuse, vertical. 1 and 4. 1 and 4. Name 2 angles that form a straight line. All right. 5 and 6. 5 and 6. They form a straight line. But 1 and 3. 1 and 3 do. And 2 and 4 do. 2 and 4. So I have no multiple choices there. If angle 1, okay, so angle 1 is 125 degrees. I want to find angle 2. Okay, so angle 2 is the complementary angle of angle 1. 180 minus 125 gives me 55, 65, 55. 55 degrees. Ooh, interesting. Is that interesting? Let's see if that's interesting. That might be interesting. Well, I guess it's not that interesting. I thought we made a mistake earlier, but maybe we didn't. Find angle 4. Find angle 4. Number 8. Number 4. Angle 4. Misspelled angle 4. Angle 4. What do you think? 125 degrees? See, it's the vertical angle of angle 1. Turning the page. Name 3 pairs of complementary angles. Okay, 3 pairs from the figure below. Number 9, we're looking at figure 2-5. Figure 2.15. So I want 3 pairs of complementary angles. Okay, so we're going to go with angle 1, angle 2, angle 3, angle 4, angle 1, angle 3. I got 3 pairs. It didn't say give me 3 angles, it said pairs, right? So otherwise I could go up there and pick that. I could pick 6, 8, and a 90, but it didn't tell me to use 3 of them, so I'm not going to. Name 2 pairs of, oh, where's the red marker? There, is that better? Complementary angles, as I was saying, means 90 degrees. So we want to find complementary angles. All right, so we'll do it again. 5 and 6. Angle 5, angle 6. Angle 7, angle 8. Where's the other one? Angle 7, angle 5. Okay, does that work for you? All right. 2 pairs of supplementary angles. All right, so here we go again. Now that we got the complementary right, we ought to be able to get the supplementary right. 1 and 2, 3 and 4. Okay, measure angle 5. Okay, measure angle 5. Okay, so angle 5 is 50 degrees. 50 degrees. Okay, so number 11, find angle 6. Well, 5 and 6 are complementary, so 90 minus 50 is 40 degrees, which is the measure of angle 6. And find angle 7. Angle 7. Okay, angle 7 is equal to angle 6, so it would be angle 7 equal to 40 degrees. We wouldn't even think about it. Angle 13, number 13, angle 2. Okay, angle 2 is a alternating, is, what is it? What's the right word? It's not alternating interior, it's a corresponding angle. Okay, so the corresponding angle to 2 is 6. And so it's the same as 6, which is 40 degrees. Number 13, angle 2, 40 degrees. Angle 4, number 14, we want to find angle 4, and that's going to be supplementary to angle 2. So 180 minus 40 is 140 degrees. And that would be angle 4. Okay. Now we get to do the next guy. We're looking at the figure below. Okay. So I think I'll draw a picture this time. Oh, where's my lines? There's my lines. Oh, all right, so we got that guy. We got this guy. We got that guy. Got this guy. And we got that guy. Oh, though you'd not like that picture. Isn't that cool? Okay, and then we have S, line S, T, L, M. And we have a right angle there. And we've got 1, 2, 3, 4, 5, 6, 7, 8. No, 7, 8. 5, 6, 7, 8. And okay, so we know that's what we know. And we also know that angle 1 is 130 degrees. Okay, so now we want to find angle 4, 8, 5, and 7. 4, 8, 5, and 7. All right, well, I'll change colors. Maybe we ought to write that as 130 degrees. Okay, so if angle 1's 130, then angle 2 is going to be 50 because they're complementary. And then angle 3 is also going to be 50. And angle 4 is going to be 90 minus 50, or 40. Angle 5 is going to be 40. If angle 5 is 40, then angle 6 has to be 50, which is also what angle 7 is, because they are vertical angles, 7. And then angle 8 has to be the same as angle 8. Angle 8 has to be 180 minus 50, which is going to be 130. All right, so now we didn't solve for what they asked for, we just solved for all of them. Okay, so we go back and say, well, I want 4. So that's number 15. I want 8. That's number 16. I want 5. Number 17. And I want 7. That's number 18. So we could just solve, it'd be just as easy to solve for everything and then go back and write down what it is. A plumber needs to connect 2 parallel pipes as shown. Find angle 1. Number 19. What do we care about plumbing anyway? Anybody know? Okay, so this is 35 up here. And we want to find angle 1 right there. Well, where do we send our wires down? A conduit. What's a conduit? Could be plastic, or it could be a piece of pipe. So as electronic guys, the electrician guys are the guys who should be running the conduit for it and running wires through the conduit. But we could end up having to do that too. And so we should know that conduits exist. How much full can we have a conduit? Anybody know? 40%. 40% full is all we can have it full. Because we need room for the wire to pull through and breathe and things like that. There's different size conduits, and bending it, you may or may not need an assistant to bend the conduit, and there's bending bars that bend it to certain degrees. If you look at the way the wiring's done in the lab, an electrician was in there for 6 months doing that wiring. Just one conduit after another one after another. Every single wire's in a conduit. Every single wire had to be run. They're all labeled. They're all just totally amazing. Only one guy did it. Yeah, he's probably a one-guy shop, and he contracted to do the wiring for that lab. And As soon as he could, he started doing it, and it was 6 months from the time he started until the time he got done. Totally amazing. And then we have to desert the lab and go to a new building and have it all done over again. Okay, well, anyway, what do we think about this? Anyway, if this is, if I go and if I think about this as a traversal going this way through two parallel lines, right? And I have one parallel line constructed like that, another parallel line constructed like this. Then I have 35 there. That means that this guy has to be 35 on this side, and that angle 1 has to be 180 minus 35, which is 145 degrees. So angle 1 would be 145 degrees in this application. Okay, number 20. And again, we probably need a better than normal picture for number 20. Okay, so we got something going. A to B, straight down to there. Thank you very much. Over to here. And we want something going that way, that way, that way. Okay. And I've got A, B, C, D, E, which are, way to go. Just thank you, author. Why can't you go in alphabetical order? A, B, C, D, E. And we know this is a right triangle. Okay, so that's what we know. And we know that angle C is 55 degrees. Okay, so that's good. We know angle CAD. CAD, this guy here, CAD, is 80 degrees, even though it doesn't look like 80 degrees. ADB, ADB, 85 degrees. And this guy is 90 degrees. Okay, so we want to find angle B, D, E. So we want to find this guy and this side right over there. That's what we're looking for. Well, and we're hampered because the one thing that we really would like to know is that the sum of the angles of a triangle are 180. Because if we knew that, then we could just find this angle and then we'd be all set, right? But this is section 1 of chapter 2, and triangles don't come until section 2 of chapter 2. So that means we're supposed to solve these things knowing things that we know. And I'm not sure I can do that. I'm not sure I can divorce myself from the knowledge of a triangle being 180 degrees and solve the problem without knowing that. But it might be possible. How am I going to do this without using that? Anybody got any bright ideas? Yeah. Okay. All right. We'll start with calling this guy angle 1 and angle 2. And this guy up here, we're going to call him 90 minus angle 2. I'm going to call him that. And on this side of it, we're going to call him 90 minus 90 minus angle 2. So this guy is the same as angle 2. Interior, okay, so those two are both going to be the same. Okay. Now this angle 1 is the same as this angle 1. We're going to go and going to extend this line out that way. This is 55 degrees because that's alternate interior angles. So now I can come up with what angle 1 is. Okay, because this is a straight line. So angle 1 is 180 minus 55 minus 80. 45 degrees? 45 degrees. So now I know that this is 45 degrees. Now I can find angle 2, which is what I'm looking for. Angle 2 is 180 minus 85 minus 45, which would be 40 degrees. 40 degrees? Really? Angle 2 is 40 degrees? Well, I mean, the picture is just a picture. Yeah, I agree with your analysis. Okay, did I do it wrong? Alternate interior, those two have to be the same. This is 85. That's 45. That's got to be 40 degrees. Okay, well, I'll go with 40 degrees. Now, if we go the other way and say the sum of the triangles are 180, then we get the same answer. This is still going to be 45 degrees, and we're still going to get that straight line, and it's still going to get 40 degrees either way. So obviously the author drew the picture wrong on purpose just to mess with us. And if you look at that 45-degree angle that he has at ABD, and the 45-degree angle is at CDA, that doesn't look like 45 degrees angle in this picture either, does it? That looks more like 20-something. So the picture's off, our answer's correct, and I solved it without using any more information than we have so far. It doesn't mean I liked doing it that way, it just means I did it that way. Okay, so that ends Chapter 2, Section 1. And now I have to